When we work with files from our Java program, those files are, of course, contained within a file system. Now, most commonly when we work with files, we're working with a computer's default file system. But Java also supports the concept of specialized file systems. And as we work with specialized file systems, they can be very different depending on what providers might exist. But probably one of the most common ones we see is the zip file system. Right? The zip file system is the ability to create and read files contained within a compressed zip file. Now, when we have a path instance, that path instance identifies a file and it's tied to a particular file system. Now, the paths class that we talked about earlier for creating path instances only works for the default file system. So we have to have some more general way of interacting with file systems and getting access to path instances within a file system. Now, there's a couple of key types we use to do that. One is the file system type. That represents an individual file system, and it contains the factory methods for creating path instances within that file system. Now, the way we get a file system is by using the file systems class. It provides static factory methods for creating a file system. Commonly, we open or create a file system, and the method we most commonly use for that is the new file system method. But of course, we need some way to identify a file system. Now, the way we identify a file system is by using URIs, right? Universal Resource Identifiers. Right? And that's kind of this generalized way of identifying different resources, right? HTTP-based URLs are one type of URI. Now, the specifics of a URI for a particular file system vary greatly between different file system providers. Again, one of the most common ones we work with is for the zip file system. Those are identified by the URI scheme jar:"file. So if we look at this URI, jar:"file/jimwilson/data/bar.zip. That means that bar.zip is a file system contained within a directory data under the directory Jim Wilson. When we interact with a file system, each file system supports custom properties. Again, the specific properties vary depending on the file system provider. But there are a few common examples we see. Things like, well, when I access a file system, if it doesn't exist, should I create it? And when I'm interacting with it, what kind of string encoding is being used in that file system? Now, to get a sense of what it's like to work with special file systems, what we'll do in the next clip is programmatically create a zip file and then interact with files contained in that zip file. Here we're in our program. In this program, we'll go ahead and create a zip file. Now, a zip file is kind of interesting because the zip file itself is just a file in the default file system. But the contents of the zip file is a separate file system. It's a zip file system. So what we want to do is go ahead and programmatically go ahead and construct all that. Now, one of the first things we have to do is specify the file that will actually be the zip file. In other words, the file that we create in the default file system. Now, all the work that we're going to do to create the zip file is in this method called openZip that I have stubbed out here. Now, what we're going to do is we're going to go ahead and call that from main. So now to set that up, the first thing I'll do is declare a variable called zipfs of type file system. And then I'm going to go ahead and call openZip. And I have to specify the path of the zip file itself. Again, the zip file is created in the default file system, so I'm just going to use paths.get to do that. So now that paths.get specifies a file called mydata.zip in the default file system. Now, there's nothing special about that file until I go out and construct it as a zip file system. Right, so what I'm going to do is go down here to my openZip method. Let's scroll down here. And in here, we'll actually create it as a zip file system. Now, remember that whenever we construct a file system, we can specify provider-specific properties for that file system. So we'll do that here. Now, the way we do that is by using a map. And the map is simply name-value pairs. So let's go ahead and declare a map with a name of type string and a value of type string. We'll call it provider props. And we'll implement it as a regular hash map. So basically, we simply have a way now to store name-value pairs. Now, the only property we need here is a create property that will set with a value of true to say that basically if it doesn't already exist, go ahead and create it. So we'll do that by simply calling provider props.put. I'm going to specify create as the name and true as the value. So now we have our properties. Now remember that when we set up our file systems, we do that using URIs. So let's create a URI variable named zip URI, and we'll go ahead and new up a URI. Now, one of the things we have to specify is the scheme. Remember, we said that with zip files, the scheme is jar:\file. So we've got that scheme. Now we want to give it the fully qualified path. Now we've had the path passed in this variable called zip path. So what we'll do now is take our zip path. We want to make sure that it's fully qualified and formatted correctly for use in a URI. So what we'll do is we'll call zip path, convert that to a URI. So we now have the path as a URI, and then we get the path back from that. Again, all we did there was say, take the path that I was passed in, make sure it's formatted correctly as a URI with a fully qualified path. And for this last parameter, we'll pass null. So that now gives us the URI for a zip file system. So now the only thing left for us to do is go ahead and create the zip file system. So I'll declare a variable called zipfs of type file system. And then we'll go ahead and take our file systems type and call new file system. And then we pass in the URI and the properties. And then the last thing we have to do is simply return back the file system. So that does all the work to create the zip file system. We simply specified the properties that we wanted, got the URI for the zip file system, and then created it. So now in order to actually do the creation, up here in our main, where we call OpenZip, whenever we open up a file system, we want to close that file system as well. We also, of course, need to handle any exceptions. So now we handle exceptions with a try block, and because we want to open and close it, we're going to use a try with resources. So I'm just going to wrap this in a try, and then we'll simply make it a try with resources there by putting it inside the parentheses. We'll go ahead and just catch all the exceptions for here, and then we'll simply write out the exception. So we have that there now. We go ahead and call into OpenZip, which will create our zip file system. Go ahead and close it automatically, and we have our catch block there. So if I just take a look at the file system, we're going to create this. Notice that right now we don't have a zip file in here. Right now, all I want to do is go back to the program. Let's put a breakpoint here right after we create the URI. Let's go ahead and run it. And so when we get here to the point where we're about to create the new file system, you can see here down in the variables, zip URI is specified as jar:\file, and then that fully qualified path all the way down to my data.zip in the default file system. Right, so we'll go ahead and let this finish. And when we do, if we go here and take a look inside of our file system, we now have a zip file. Right, so we've successfully constructed a zip file. So in the next clip, we'll take a look at how we can copy files into that zip file and create files directly within the zip file. So now we know how to create our zip file. Right, so let's look now at how we can actually first copy a file into the zip file. So I've got this file here, file1.txt. Right, if I open that up, right, simply the letters A through Z. So let's go ahead and delete our zip file. Go back to our program here. And what we want to do now is that we've got this method here, copy to zip stubbed out, that accepts the zip file system. So up here in our main, we'll go ahead and call copy to zip, passing in the zip file system. So we have that there. So let's go down here and copy to zip, and we want to actually do the copies. Now what we're doing is we're copying that file1.txt from the default file system. So we'll first just get our path for that. So we'll declare a variable called source file of type path. And then what we want to do is take our paths.get for file1.txt. So that gives us a path to file1.txt in the default file system. Now what we also want to do now is get a path for our destination file. So this will be a path that points to the contents, or I should say points within the zip file. So I'm going to declare a variable called dest file of type path. And what we want to do here is go to the zip file system and get a path through the zip file system. So I'm going to say zipfs.getPath. And then this will be the path name within the zip file. So what I'm going to do here is say, I want it at the root, so I'll put a slash. I'm just going to say file1copied.txt. Now, of course, I can name it anything I want, including file1.txt, but I just wanted to give it a different name so you can see that we can name it whatever we want to. So now, one thing to notice here is that we're using paths to get things in the default file system, but for other file systems, we have to use the file system itself. Well, it turns out that's because this path is just a shortcut. Another way that I can actually get a path within the default file system is to actually use the default file system. So I'm going to go ahead and comment out this source file here. I'm going to declare another path source file. And what I can do here is I can actually say file systems dot get default. And then now I've got a file system that represents a default file system. So from there I can call get path and pass in file1.txt. So that's kind of the longhand way of getting a path within the default file system. That paths class simply gives us a shortcut, or I should say a shorthand for doing that. So I'm going to go ahead and comment out this one and go ahead and use the one we normally use. So now I've got both paths, right? The file that I want to copy, which is my source file, which is in the default file system, and then a path for a file within the zip file system. So all I need to do now is go to the files class called the copy method, pass in my source file and my destination file, and then I have to pass in some options telling it what to do. And when I pass in an option, it simply says that, well, if there's already an existing destination file, replace it. So now if we head back up here to main, right, all we're doing is creating the file system and then copying a file into it. Right, so if I go ahead and run this, and I go look at my file system, notice I've got my mydata.zip. If I open that guy up, notice there's a file1 copy.txt, double click, and I've copied the file into there. So we see how easy it is to copy file into the other file system. Let's go ahead and delete our zip file again. Now, in addition to copying files into it, we can actually create files directly into the file system. So I've got a couple of methods stubbed out down here. Scroll down here. We've got a write to file in zip1 and write to file in zip2. Notice they take the zip file system and then a string array. Right, if you go back up here to main, I've got that string array. So what I'm going to do here in my try with resources is call each of those write methods. All right, let's go down there and actually write out to the files. Now, so first, in the write to file in zip1, let's go ahead and use just a regular buffered writer to do this. So we'll create a buffered writer within the zip file system. So I'm going to put a try with resources here. I'm going to declare a buffered writer named writer. And I'm going to go to my files.new buffered writer. And I'm going to pass in a path that points to a file within the zip file system. Right? So I'll use my zipfs.getPath. So you notice that I'm not doing anything special to write into this alternate file system other than get a path within the file system. So I've got that all set up there. So I've got my try with resources. And so now I just want to iterate through the array. And then for each element in the array, I'm going to write it out and then put a new line after each one. So that's the way we've been writing out the files kind of up to now throughout this module, right? So kind of iterating through things and writing them out one by one. And you can see that works just fine with any of these file systems. But also, I may go down here to this write to zip file 2, or I should say write to file in zip2. We can actually use one of the file classes to simplify that. Remember we said that the files class has a write method. So let's go ahead and call that. Now it wants the path, so we'll go ahead and put a path inside the zip file system. So we've got that path. We want to write out the contents of the array called data, so we'll put that there. Then we have to give it some other information. We'll tell it what character set to use. We want to use the default character set. And also, we would give it some options on what to do. So we're going to go ahead and say, I want to use a standard open option of create. So we want to say, go ahead and create that file. Now, you'll notice that as we pass this in, we're actually getting an error. That's because the value that's written out has to implement the interface iterable. And the string array doesn't do that. But we can convert that string array to a list, which would then implement the interface. I'm going to call the arrays class.asList method. And so that now converts that array of strings into a list of strings which implements the required interface. Right, so we can write to the file using the traditional buffered writer as we did into write to file in zip1, or we can take advantage of this files.write method that does all the work of opening up the file, writing out the contents, putting the new lines in, and closing it. Right, so we scroll back up here to main. Right, so we call each of our methods now. Right, we go ahead and create the zip file, copy into it, and then write into it the traditional way, and then write into it the new way. So let's go ahead and run this. All right, it completes. We look at our file system. So we go into our zip file. We've already seen the file that was copied, but let's look at our new file1.txt. Right, created using a buffered writer, as we've talked about before, or our new file2.txt, created using the files.write. So we can see there that using the zip file system, we can do all the things we can do with the standard file system. To wrap up, some of the key things you want to remember from this module. Remember, we first looked at the java.io package, and that had all of our stream-based I/O types. And it also had legacy file and file system types, right? And those were the streams that were very tied to files themselves. We don't want to use those in our new code, but you want to be aware of them because there's still a lot of code out there that uses them. Then we looked at the java.nio.file package, and that had our current file and file system types. We saw a lot of examples of working with those. We talked a lot about working with streams. Remember that streams are an ordered sequence of data. Any given stream is unidirectional, right? It's either for reading from or writing to. Remember that streams are broken out into two general categories, either binary or data-oriented, and then character-based, or Unicode-oriented. Working with them tends to be very much the same. In other words, they have very much the same operations. They just interact with the content at different levels. And remember that streams can be chained together, so that you can actually have one stream do some basic level of work, and then chain it with another stream to add some higher level of work with it. We talked about try with resources. Remember that try with resources automates resource cleanup, right? It takes care of closing it down. And it works with any type that implements the auto closable interface. We talked about it a lot in terms of streams themselves, but a lot of different types work with try with resources. Then remember some of the key types we talked about. Where we had the path type that locates a file system item, like a file or a directory. And remember that a path instance actually includes the file system. So when you get a path, it references not only the item within a file system, but the file system itself, right? Such as the default file system or a zip file system. We had the paths type, and that was really a convenience class, right? It had factory methods for creating path instances from the default file system. It just saves us from going through the overhead of getting to the default file system and then getting to a path, right? Really about convenience. And then we had the files type, and that provided methods for interacting with files. Right, so we could create files, we could write to files, right, we could copy files, those sort of things. And then the last type we looked at were related to the file systems. Right? So we had the file system type, which represents a file system. Now, of course, that can be the default file system, or it can be a specialized file system, such as the zip file system. Remember, the file systems are identified by URIs. For example, the zip file system is represented by URIs with the scheme jar:_file. And then finally we had the file systems type, which were just methods for creating and opening file systems. All right, that's it for this module. In the next module, we're going to take a look at string formatting and regular expressions.